Hello everyone, I'm Mrs Jennison and I'm an Associate Director for Outward Grange Academies Trust. Welcome to our lesson on cabbage indicators and neutralisation. This is a lesson in the Fizz and Pop topic. Before we start, it would be really good at practice to have your planner with you, as there is a copy of the pH scale within it. And also now would be a really good time to turn off any notifications so that you don't get distracted during the lesson. It would also be a good idea to have a pen and paper ready so that you can take part in the activities as we work through the lesson. Our challenge today is to be able to describe how to make indicator from red cabbage. Our aspires to be able to explain how acids and alkalis react with each other. In the previous lesson, I talked about making an indicator from red cabbage, and it's a very simple process. You can just chop the cabbage, boil it for a few minutes, strain it and let the filtrate cool, and then use that as an indicator. Now this indicator will change colour based on the pH of the substance as shown in the scale on the screen. It will change red in acidic conditions, and it'll change from purple to green to yellow in alkaline conditions. This is because there is a chemical within that red cabbage which will change based on the pH. Now once you have made an indicator, you can then use it to test a variety of acids and alkalis. Now, how can we make red cabbage indicator? I'd like you to give the equipment we would need and write a short method for this process. Now the equipment you would use will be a Bunsen burner, tripod and gauze, red cabbage cut, a beaker, filter paper and a funnel, a spotting tile and a pipette. That's if you were doing this in a lab. If you were doing it at home, instead of the Bunsen burner, tripod and gauze, you would use a pan and your hob, and instead of your filter paper and funnel, you would probably use a sieve or a strainer. The method is to heat water until it boils, add the red cabbage and boil for a few minutes, filter the cabbage and collect the filtrate, which is the liquid, leave that to cool and then use the cooled cabbage indicator to test a variety of substances by adding it to the substance with a pipette in a spotting tile or in small glasses if you were doing this at home, I actually used an artist palette when I did it at home. You'll see that in a few slides. Now, as I've already said, I did this at home and I actually compared it to my results from the previous lesson where I used indicator paper so that we could compare the results, and that's what we would do if we were in a lab to test how good the indicator is compared to universal indicator. Now here on the first image you can see the setup for the day. So I had my little protective screen on my table, and then I've got my first photo which shows what I showed you last lesson, which was the universal indicator paper in each of the substances, and the photo on the right is the colour changes when I added red cabbage. Now you can see the colour changes are different to what there would be with indicator paper, so I had to keep comparing to that image on the previous slide which showed you the colour changes of the red cabbage indicator for each pH. From that experiment I've placed the results that I've got into a table. I'm going to give you some time. I'd like you to look through each row and just jot down anything you notice about these results. Now, what you may have noticed is quite frequently the pHs didn't quite match up between these two indicators. You could typically tell whether something was acid or alkali, but the pHs weren't exactly the same. Now, this is due to what I discussed with you in the last lesson about it sometimes being quite difficult to match the colours exactly to the scales. These are quite subjective because you are converting a colour that you are observing to a pH. So actually it would be much more accurate to use something like a pH probe, which you would just simply put into the substance and it would give you a digital readout of the pH of that substance. So now that we've spent a fair amount of time looking at indicators and pHs and acids and alkalis, it's time for us to have a look at neutralisation. Now, we've used the term neutral quite frequently to describe a substance that is neither acid nor base, but acids and alkalis can actually react with each other to form a neutral substance, and that reaction is called neutralisation. A strong acid will neutralise a strong alkali, and a weak acid can neutralise a weak alkali. As you add acid to an alkali, the pH will decrease until it gets to 7, and that's when we've neutralised the alkali. And if you add alkali to an acid, the pH will increase. Now, in that neutralisation reaction, we are reacting an acid with an alkali or a base to produce a solution of salt and water. Now, hydrochloric acid, as we saw in a previous lesson, is pH 1. If I add an alkali, for example, sodium hydroxide, to that hydrochloric acid, we would be wanting a neutral substance to be produced at the end. But to do that, we have to add the correct amount, as if we added too much alkali, the pH would continue to increase until we end up with an alkali solution. Now, in this example, hydrochloric acid has been reacted with sodium hydroxide, and the salt formed is sodium chloride, which is the salt that you put on your chips, although I would not expect you to do that with the results of this experiment, as there is universal indicator in there also. The reason this happens is because all acids contain hydrogen ions and all alkalis contain hydroxide ions. So when we react those two things together, that is how the H2O forms. The hydrogen ion reacts with the hydroxide ion, forming water. And it's the other chemicals in there that form the salt. Just a quick summary of that at the moment. So what do all acids contain? What do all alkalis contain? And I'd like you to also write the word equation for neutralisation. All acids contain hydrogen ions, which can be represented as a H with a tiny plus up in the air like a square, but it's called superscript. All alkalis contain hydroxide ions, which are OH, both capitals, with a superscript minus. And the word equation for neutralisation would be acid plus alkali forms salt plus water. Now, how we could make sure that we add the right amount of alkali to neutralise an acid would be following the steps seen on the screen at the moment. First, you would pour some acid into a beaker and some alkali into another beaker and add a few drops of universal indicator. Then you can take a small sample of the alkali using a pipette and add it a drop at a time to the acid and swirl and mix after each drop. Then you can stop when the colour changes to green. So how do we know what salt we are forming? Now, I said earlier that the name of the salt depends on the acid and the alkali you are using. So in the example you can see at the moment, if sulfuric acid reacted with sodium hydroxide, the salt we would form would be sodium, and that part of the name comes from the alkali, sulfate. The second part of the name comes from the acid, and we would form water. So let's have a look at another example. If I was to react sulfuric acid with potassium hydroxide, I would form potassium sulfate and water. Potassium again coming from the alkali, and again sulfate coming from the acid. Let's have a look at one more example. You may be able to do this one with me. If I was to react magnesium hydroxide with sulfuric acid, I would get magnesium sulfate and water. So remember, the first part of the salt's name comes from the metal that is in the alkali. Dependent on what acid you use, the second part of the salt's name corresponds to that acid. So hydrochloric acid would make chlorides, sulfuric acid would make sulfates, nitric acid would make nitrates. Now, if you want to, you can have a go using those rules there. I've not put a timer on this, but if you do want the time, you can pause and have a try, and then we'll go through the answers. So sodium hydroxide plus nitric acid would make sodium, nitrate and water. Calcium hydroxide and hydrochloric acid would make calcium chloride and water, and lithium hydroxide and sulfuric acid would make lithium sulfate and water. Indigestion is caused by your stomach acid. How could we cure a bad case of indigestion? So to cure that indigestion, we actually need to neutralise the acid. And to do that, you would ingest an alkali or base. Now, I'm going to stress here, you would only use an alkali or base that is specifically made for this cause. Okay, you wouldn't want to take just any. It has to be an indigestion remedy, but inside that indigestion remedy is going to be an alkali or an insoluble base. Now we see this in other contexts as well. So in the previous lesson, I told you that nettles contained an acidic substance, and it's that acid that causes the pain when you are stung by a nettle. Now, when you rub a dock leaf onto that nettle sting, you are applying an alkali to that nettle sting, which will neutralise it. And a lot of over-the-counter sting relief is actually an alkali. I have a little quick quiz. I'll give you 10 seconds to think of each one. When we react an acid and alkali, we make salt and water. Which is the correct word equation when we react an acid with an alkali? And it is sulfuric acid plus sodium hydroxide makes sodium sulfate and water. Which is the correct word equation when we react magnesium hydroxide and hydrochloric acid? It is, again, the bottom one. Magnesium hydroxide plus hydrochloric acid makes magnesium chloride and water. So as you move towards GCSE, you may start to use some ionic half equations to represent this, but just for now, remember that in neutralization reactions, the acid hydrogen ions react with the alkali hydroxide ions to produce water. Just one last set of questions for you to have a go at. Again, I'll put a timer on the screen, but that is just a guideline. If you need longer, feel free to pause the video and I'll just read through it with you before you start. So ammonium nitrate is used as a garden fertiliser. It is manufactured by the reaction between ammonia gas and nitric acid. The diagram below, well, it's actually to the side here because I've moved it, represents the stages in the process for making ammonium nitrate. So ammonia and nitric acid react to give a solution of ammonium nitrate. Ammonia is an alkaline gas. In stage A, an alkali reacts with an acid. What effect does an alkali have on an acid? The formula for ammonium nitrate is NH4NO3. How many different elements are there in ammonium nitrate and how many different atoms are represented in the formula for ammonium nitrate? Potassium nitrate is also a fertiliser. It can be made from the reaction between potassium hydroxide and an acid. Complete the word equation for the reaction, naming the acid used. When an acid reacts with an alkali, it is neutralised. There are 3 different elements in ammonium nitrate and 9 atoms. To complete the equation, the potassium hydroxide would react with nitric acid as you are making a nitrate, and water is also formed. That's everything from me this lesson, and I shall see you soon. Bye!